Okay, here's the question. VABC is a regular tetrahedron of side x cm. Part A. Express the height of the tetrahedron in terms of x. B. Find the angle between VA and the face ABC. And C. Find the angle between the face VAB and the face ABC. So what is the meaning of regular tetrahedron? That means it's a four-face solid. All of each face are the polygon, and each face is a equilateral triangle. So you need to draw it first. Here you can see there's a 3D figure VABC. Each faces are equilateral triangles of side x cm. The problem is you need to find the height of the tetrahedron. That means from one of the vertices and then project to the opposite faces. So we can do it in this way. We draw a line from V to the face ABC. We project point V to the face ABC. We call it as point K. But the problem is, how do we find the length of VK? We can think in this way. We can draw a line AK. As you know that when we project a point B to the face ABC, the red line VK will be perpendicular to the face ABC. That means VK will be perpendicular to the line AK, and it forms the right angle triangle VAK. As you know that VA is the side XCM. If you want to find the length of red line VK, what you need to do is find the length of the green line AK. So let's consider the triangle ABC. That's the graph. Triangle ABC is an equilateral triangle. You need to find the length of AK. So what can we do? You need to pay attention is K actually lying on the axis of symmetry of triangle ABC. That means it lies on CM, and CM is the height of the equilateral triangle. Of course, the length of CM could be found easily. So, how can we find AK? There are two methods. First one, ABC is an equilateral triangle. Therefore, K will be the centroid of the triangle ABC. So CK to KM will be in ratio 2 to 1. And you can find KM and then use Pythagoras theorem to find AK. Second method, since this is an equilateral triangle, therefore K will also be the incenter of triangle ABC. And that means AK will be the angle bisector of angle CA. Therefore, KAM, this angle will be 30 degrees. Then you can find AK. So let's start the work. Let K be the projection from V to the face ABC. And hence, note that K is the incenter of triangle ABC. Therefore, angle KAM would be 30 degrees. In the small right angle triangle KAM, you can use trigonometric ratio to find AK. MA over AK would be cosine 30 degrees. So what is AK? MA would be 1 over 2 times x. because AB is xcm, so AM would be the midpoint of AB, so MA would be 1 over 2x. AK times cosine 30 degree. Cosine 30 degree, that is square root 3 over 2. So x would become AK times root 3. And therefore AK is equal to x over root 3. Now consider the whole figure in triangle VAK. We can use Pythagoras theorem to find VK. VK will be equal to VA square, that means x square, minus AK square, that means x over root 3 bracket square. So VK will become x square minus x square over 3, and inside the square root sign, this becomes 2x square over 3. And x square and x square root become x. Numerator square root 2, denominator square root 3. Now rationalize the fraction. Both numerator and denominator multiply square root 3, then you get square root 6 over 3 times x. That's the answer of part A. The height of the tetrahedron is square root 6 over 3 times x. So part B, you need to find the angle between VA and the face ABC. So the required face angle is angle VAK actually. So you can use the trigonometric ratio to find this angle VAK. In this triangle VAK, cosine angle VAK would equals to AK over VA. AK, that is x over square root 3 as found in above, and VA will be x. So simplify the complex fraction. You will get as 1 over root 3. That's independent of x. Cosine angle VAK equals 1 over square root 3. Therefore, angle VAK is about 54.7 degrees, correct to 3 feet. In part C, you need to find the angle between VAB and the face ABC. So the common line, that means the intersecting line, will be AB. And for each line, for each faces, you draw a line perpendicular to AB. So that is VM and CM. And the required angle is angle VMC. And the problem is, how do we find VM? That's easy. You can use Pythagoras theorem to find VM. In triangle VBM, x squared minus x over 2 bracket square and x square root. That is square root 3 over 2 times x. And similarly, CM equals to VM, because they are talking about the height of the equilateral triangle. And you can use the cosine formula in triangle VCM to find the angle VMC. It seems big, but after you simplify it, that's a very simple answer, 1/3. Then you get the angle between these two faces, that will be 70.5 degrees, correct to 3 feet.